so tired of understanding math.
Babe, you're leaving again.
Feeling down and stuck with your math assignment?
Who's that?
Hey there! Our team is here to make the math easy for you. Just search on YouTube T for Bascal and it will help you to ace your homework as you learn with our team.
Hey! Are you having a hard time finding the derivatives of algebraic function? Worry less! We are here to help you. Introducing the fundamental tools in calculus, the differentiation formulas. First, let's define the differentiation formulas. Differentiation formulas are used to find the derivative of a function with respect to its independent variable. At any given point, the derivative represents the rate of change or slope in a function. At this moment, I'll let Ms. Pena help you with the derivative of a constant, Ms. Borromeo with the derivative of a sum, and Ms. Tingson with the derivative of a power, and derivative of a constant multiple, and finally, Mr. Santor will discuss the derivative of a product and the derivative of a quotient. In order to enhance and make it easy for you to understand the differentiation formulas, our friends provide 3 examples in its differentiation formula.
What is the derivative of a constant? The derivative of a constant is fx equals c, where c is a constant. Then f prime of x equals to 0. The derivatives of a constant is equals to 0. I will give you some examples. Square root of -3, since this given is a constant and it doesn't have a variable, so the answer will be equals to 0. Same to the first example, 5 is still a constant, so the answer will be equals to 0. Lastly, same process with the previous examples, the derivative of a constant is equals to 0.
Now for the next rule, it will be derivative of a power. It is simply bringing down the exponent or the power of x, then multiplying it to the function, and then subtracting 1 from the exponent. For better understanding, here's the examples. For example, find the derivative of x raised to 4. The first thing that you need to do is to bring the exponent to the front. So from the given x raised to 4, it will be 4x raised to 4. Then after bringing it down, apply the rule of nx raised n minus 1. So if we write it down, it will be like this. 4x raised to 4 minus 1. So the derivative of x raised to 4 will be 4x raised to 3. Another example, x raised to -5 will be -5x raised to -5. Then after bringing it down, apply the rule of nx raised n minus 1. So if we write it down, it will be like this. -5x raised to -5 minus 1. So the derivative of x raised to -5 will be -5x raised to -6. And for the last example, if the given is like this, we can write it down into exponential form. So this will be x raised to 1/2. Now, we can identify the derivative of x raised to 1/2. Same as the first and second example, bring the exponent to the front. So the exponent of the given is 1/2. If we will write it down, it will be like this. 1/2 x raised to 1/2 minus 1. So the derivative of the square root of x will be 1/2 x raised to -1/2. Now, let's proceed with the derivative of a constant multiple. The constant multiple rule states that the derivative of a constant multiplied by a function is equal to the constant multiplied by the derivative of a function. To help you understand it better, Let me show you this example. For the first example, negative 10x raised to 5. The first thing that we need to do is to identify the constant and the function of the given expression negative 10x raised to 5. The constant is negative 10 and the function is x raised to 5. We can now determine the derivative of the given function by simply copying the constant negative 10, then deriving the function with respect to x. The derivative of x raised to 5 is 5 times x raised to 4. Why does the exponent 5 became a 4? Don't forget the rule nx raised to n minus 1. So if we write it out, it will be like this. Negative 10 times x raised to 5 minus 1, and the final answer is negative 50 x raised to 4. For another example, find the derivative of 3x raised to 3/4. The constant is 3 and the function is x raised to 3/4. Now, we need to do is to copy the constant, which is 3, then multiply it to the derivative of x raised to 3/4. So 3 times 3/4 times x raised to 3/4. Oops, don't forget the rule nx raised to n minus 1. So in here, 3x minus 1 is equals to negative 1/4. So if we write it out, it will be like this. 3 times 3/4 x raised to 3/4 minus 1. And the final answer will be 9/4 x raised to negative 1/4. Now for the last example, let's find the derivative of 1/2 x raised to 1/2. Constant is 1/2 and the function is x raised to 1/2. 1/2 times 1/2 x raised to 1/2 minus 1. So the final answer will be 1/4 x raised to negative 1/2. So the derivative of 1/2 x raised to 1/2 is 1/4 x raised to negative 1/2.
And now, let's tackle the derivative of a sum. Just remember, the derivative of sum is equal to sum of the derivative, meaning we will get the derivative of each function separately. Let's have here the 3 examples of the derivative of a sum. Let's multiply the constant to the exponent and minus the exponent to 1. 4 times 4 is 16. 4 minus 1 is 3. So, the derivative of 4x raised to 4 is 16x raised to 3. 2 times negative 5 is negative 10. 2 minus 1 is x. The derivative of 7x. Since variable x has 1 exponent, 1 times 7 is 7. 1 minus 1 is 0. Any variable that has a 0 exponent will be cancelled, so the derivative of 7x will be 7. Since 9 is a constant and has no variable in it, it will be equal to 0. Let's find the derivative of 3x raised to 3, negative 4x raised to 2, plus 8x and plus 3. Since we promised that we will provide 3 examples for each differentiation formulas, here's the third example. Let's find the derivative of 5x raised to 4 plus 4x raised to 2, negative 6x, and negative 2.
Now, let's try and solve this new derivative, the derivative of a product. The derivative of a product is a specific rule in calculus used to find the rate of change of a function that's the product of two other functions. Here's an example. The derivative of 8x raised to 3 minus 2 is multiplied to 3x plus 5. X raised to 3 minus 2 is multiplied to 3 plus 3x plus 5 is multiplied to 24x squared. And then combine like terms. 72x raised to 3 plus 24x raised to 3 is equals to 96x raised to 3, and bring down the rest of the terms. So the final answer will be 96x raised to 3 plus 120x squared minus 6. Here's another example. the derivative of 3x raised to 5 plus 7x multiplied to 7x squared minus 4. Our f of x here will be 3x raised to 5 plus 7x, and 7x squared minus 4 is the g of x. Same as we did with the first example, substitute the following so it'll be 3x raised to 5 plus 7x multiplied to 14x plus 7x squared minus 4 multiplied to 15x raised to 4 plus 7. And substitute the following. 8x raised to 3 minus 2 is multiplied to 3 plus 3x plus 5 is multiplied to 24x squared. Then distribute, which will give us 42x raised to 6 plus 98x squared plus 105x raised to 6 plus 49x squared minus 60x raised to 4 minus 28. And combine like terms. 42x raised to 6 plus 105x raised to 6 is equals to 147x raised to 6. And 49x squared plus 98x squared is equals to 147x squared. And bring down the rest of the terms. So the final answer will be 147x raised to 6 minus 60x raised to 4 plus 147x squared minus 28. And here's the last example to further sharpen your math skills. The derivative of x raised to 6 minus 9x raised to 3 is multiplied to 8 plus x squared. Another part of differentiation formulas is the derivative of a quotient. Quotient rule in calculus is a method for distinguishing problems in which one function divides into another function. The derivative of a quotient in calculus is found using the quotient rule. To help you understand it better, let me show you this example. Given the derivative of x squared plus 4 all over 6x plus 2. To be able to write it in the formula, you first need to find the derivatives of f of x and g of x. In the given expression x squared plus 4 over 6x plus 2, f of x is x squared and its derivative is 2x. For g of x, which is 6x plus 2, the derivative is 6. The constant numbers will automatically be always 0. Now, you can start distributing the value 6 and lastly combine like terms. 12x squared plus negative 6x squared is equals to 6x squared. So the final answer will be 6x squared plus 4x minus 24 all over 6x plus 2 squared. Here's another example of a derivative of a quotient. The derivative of 6x plus 3 all over 4x minus 1. And we'll have the final answer as negative 18 all over 4x minus 1 squared. And for the last example, the derivative of a quotient, let's find the derivative of this function, the derivative of 2x raised to 3 plus 4 all over x squared minus 1.